Let's take a look at how we can implement the idea of encapsulation in a Python program. For this video, I'm making an assumption that you understand a couple of things before we get started. First of all, that you understand just on a very basic level what object-oriented programming is. Maybe you're not very good at it. Maybe it hasn't quite clicked why it's important or how it's useful. But you've at least been exposed to it. You've created a class before. Some of that vocabulary is not new to you. So that's one assumption. The other assumption I'm going to make here is that you understand what encapsulation is and why that's important to us. And in the case of encapsulation, if you need to get up to speed on that, there is a separate video on that topic that you really should view and make sure you understand before we move on to this in Python. For this example that we're going to go through, we're going to create a very simple bank account class. Now, a bank account is one of those kind of stereotypical examples that teachers tend to use along with a car or like a dog or cat or something like that. So this isn't a very creative choice on my part, but it lends itself well to a very simple and relatable example that we can take a look at. So my bank account class, I've come up with 3 attributes, and notice, by the way, that now that I know that those attributes are going to be variables in my code, I've written them out with variable style names. So we're going to have an account number, the owner's name, and then we're going to maintain a balance of how much money is in that account. And I don't have any behaviors yet because we're going to start out and look at this class from a perspective of not using encapsulation and as a way of kind of showing why it's important and how it works mechanically when we implement encapsulation. So we're going to have to get to those behaviors later. With that set up, let's go ahead and take a look at some code. All right, so this is my basic implementation of the bank account class that we saw in the diagram. I'm not going to spend a lot of time on this because, like I said, I'm assuming that you have done a little bit of this kind of stuff before viewing the video. But I will point out that those 3 attributes that are on my class diagram, they show up here in the form of what I might call instance variables, right? They're in this init method, which you're going to hear me refer to it as a constructor. Which is kind of the object-oriented way of saying it. And this is the method that runs when we instantiate an object, and it can do other things, but its primary purpose is to kind of establish default values for those for whatever instance variables we're going to have. I also have a print account info method just for mechanical reasons so that I can print stuff out easily as we're working. And I used code folding to hide that because I don't have a lot of screen real estate. But all this does is print out the data. It prints out the instance variables. I'm using a very kind of basic way of making it look like currency. If you want probably what is considered the better way of doing that, or the more industry standard way of doing it, you can search for the locale module, and it's very easy, but I just felt like that was beyond the scope of what we're doing here. So I'm going to fold that out of the way again. And then last but not least, I have a little bit of test code. I am creating a bank account object. And remember, we call this instantiation because I'm creating an instance. And I can have as many instances as I want. I could have test account 2, test account 3, and so on. The parentheses at the end of this, remember parentheses always refer to a function or a method, and that's actually referring to this constructor. So what this says is that to create this object, it's going to run this constructor code and then assign the object that is created to the variable named test account. And then I'm just going to print it out to see how it looks, make sure it got those default values. Again, I have not a lot of screen real estate here, but down in the terminal, I can see that everything looks good so far. Now, this simplified implementation of a bank account that I've put together here does not use the idea of encapsulation. And so what that means is that all three of these instance variables are accessible to anyone and anything in our code that wants to come along and manipulate them. So this is very possibly the way you have always used classes, and it makes it very easy to work with. So if I want to give this bank account a little bit of money, I can just access that balance variable and say, okay, I'm going to give them $500 here to start out with, and I will execute my code just to make sure that is working. And it is working. The account now has that $500 that I added to the balance, or that I put into the balance, maybe is a better way to say that. This is fine in many cases, but the idea with object-oriented programming, if we're going to work in this paradigm, is that we want to protect our data and just allow the minimal amount of access. And so in this video, I'm going to give silly examples that aren't really very realistic, that just are meant to illustrate the point. It's not that I think this is a real danger, but for example, what if somebody comes along and does this? If I can type my name correctly, I have now taken over the account, right? I came along and I changed the name to Tim McMichael. The idea here with encapsulation is that maybe we don't want people to just be able to change things however they want. We want them, we want that data to be encapsulated, protected, so that we can manage any changes that happen to it. So, if somebody's going to change the name on a bank account, there's a bunch of stuff that has to happen, right? We need to get a copy of their ID. There's probably all kinds of paperwork. So if we have a method that manages this, then we can make sure that nothing happens that is not supposed to happen. So let's see how that encapsulation is going to work. Okay, great. So we have now, we've let other people know, other developers know, that they really shouldn't be messing with this owner name, and hopefully they're also object-oriented programmers and they don't kind of break that rule for us. But what if we need to take it a step further? What if we boy, this variable is really, really important that it doesn't get manipulated? For example, the account number. An account number, much like your student ID, is probably going to be this unique identifier that ties all of the bank's data together, all the bank's data that's related to this one account. And so if somebody were to change that might have a ripple effect all over the place, where we might sort of lose our connection to all those other pieces of data. So it's really important that we don't edit that. Is there anything we can do? There is one step further that we can go. And what I'm going to do is, it's again a question of renaming that variable. But this time, instead of one underscore, we're going to use two underscores. And incidentally, I'm using that rename function, which on my Mac is the F2 key, because I've referred to this variable elsewhere, like in this print account. And so I'm doing that so that it fixes it everywhere, changes it everywhere. Okay, so I've added two underscores to the front of the name, and it is kind of a marker. It's, you can think, well, really, I'm really, really serious. Please don't edit this. But it is more than that, because what Python will do when it sees a variable name, an instance variable name starting with two underscores like that, is it will use a feature that they refer to as name mangling, where it will essentially encapsulate that for us. So if I come down here to my test code, and let's give this a shot, I'm going to say print, and I'm just going to print the test account dot, and I'm going to say underscore account num, and let's see what happens when I run that. So the error I get is that bank account object has no attribute underscore account num, right? It actually does, we just can't access it this way. This still isn't as strong as encapsulation with the private keyword in a language like Java, because there is still a way, like if somebody is really insistent on accessing it, they can get to it. And let's see if I can remember the syntax, because I don't do this, and so I don't. This feels wrong to me. But I think we can say underscore class name dot underscore account name. I can't remember if that dot is necessary or not. Let's see. Nope. I think maybe if we get rid of that dot. There we go. So there is a syntax that lets me access it still, and that is read and write access. But now this person has had to really go out of their way to access it, and hopefully, I mean, there's nothing we can do to stop that, or nothing reasonable we can do to stop that, because in Python it just doesn't have that strong private access modifier. But this at least gives us that sense that, like, if somebody's going to do this, they are doing it very intentionally, and maybe that's okay, maybe it's not, but we can't stop it. Okay, so through the magic of video editing, I'm going to give us some methods to go with that. Okay, and so I came up here and I created a get account number, and I've tested that down there. Now, this is, again, where we can be thoughtful about our encapsulation. We do need people to be able to find out the account number, right? So we have to give them access to read it, but we don't give them access to change it. So I didn't create a set account num method. That's one way that that's one basic decision we can make about controlling that access. So I think I'm done with those two variables. We haven't gotten to the big one yet, the balance. But what I want to point out here is that these get and set methods are very formulaic at this point. Again, I don't have any code here doing anything to stop the changes, but we're still at least we're still implementing by object-oriented programming rules. And we refer to these methods as, the nerdy name is that the get methods would be accessors and the set methods would be modifiers, but I think many of us just refer to them as getters and setters. It's a naming convention that is fairly universal, so we definitely want to stick to that whenever we can. And I always like to point out that we're returning this information, we're not printing it. The only method I have up here that does any printing is this one at the bottom, and I put print in the name because I want to make it clear that if you call this method, it's going to produce output. Okay, so the last variable up here to deal with is the balance variable, and so I'm going to rename that, and I'll use the name mangling approach here with two of those. And now balance is important. We need to be able to change the balance. It's not something that never changes, but the idea is that we don't just go and change the balance without something happening. There has to be an action that corresponds with it. Actions mean methods, right? The actions that can impact the balance of an account are two things, basically, a deposit or a withdrawal. We can either add money to our account or we can take money out. And so I do need to have a get balance account because we need to be able to find out what the balance is. So I'll start with that. Get balance. And again, it's just real formulaic, especially for the getters. It's just returning that value. And it's real straightforward. But we don't want, just like with the account number, we don't want to set here. We don't want a setter method. We need a method to deposit and a method to withdraw. And so I like to put my methods, by the way, under my getters and setters. I'll leave print down at the very, very bottom because that's really just something I made for the purpose of the video. So let's make a deposit method. And if we're going to deposit something, we need additional information. We need to know how much money are we depositing. So I'll call that the amount. And now I'm going to say that self.balance. And the way I'm going to modify this is I'm just going to add on whatever that amount is. Okay, so that should increase the balance by whatever amount I specify. So now instead of saying test account balance equals all that stuff, we're going to call the method. Oops, deposit 500. So now we'll deposit that 500. I'm going to turn off that code and just turn on the code that prints out the account information. And sure enough, we have $500 now because we have made that $500 deposit. And we can do the same kind of thing with a withdrawal method. Oops, I accidentally ran that again. So again, we have to know how much money we're going to take out of the account. And now we're going to say self.balance minus equals the amount. But the problem is, hopefully the problem is fairly clear here. If I withdraw, let's say I want to withdraw $1,000, it let me do that, and it let me go to a negative 500. Now, banks, of course, you can get a negative balance, and then you pay all kinds of fees, and it's a good way for the bank to make a bunch of money on you. But for the purposes of this demonstration, we're going to just say, well, that's not allowed. We don't allow our customers to go below 0. So this really gets to the heart of how we use encapsulation to monitor the way our values are adjusted. Is we can add some code here that says, well, we're only going to allow the withdrawal if they have enough money for it. So if the amount is less than or equal to the balance, then that's allowed, right? So a simple if statement, nothing fancy about that unless Tim managed to mangle it while he was typing it. But what we did now is we deposited $500. That seems to have worked, but then when we went to withdraw $1,000, it did not work. Okay, just to be thorough here, let's change that to withdraw $100. That should work, and that should give us $400 left, and it did. So our withdraw method is working correctly. And one last thing I want to show you with this, just to show you some of the things that are kind of possible, is maybe we need to, in our other code, maybe we need to know whether or not that withdrawal worked, right? Like the program's going to do one thing if the withdrawal was successful, but if they didn't have enough money, it's going to need to do something else. So what we can do is we can have our withdraw method return some value that indicates whether it was successful. And often you can imagine this might just be like a Boolean return. It might just say true if it worked. It might say false if it didn't. But we could also just return the new balance, right? We could return whatever the current balance is. Oops, I forgot my extra underscore there. And so that should still work. That doesn't change anything because in our test code, now when I call withdraw $100, it's returning that 400. I'm just not doing anything. I could have a little, I could have a little assignment statement there that saves that. But let's kind of finish the train of thought up here. What happens if they don't? It doesn't do anything. It doesn't return anything. So let's just add an else statement here that says return. And I've said this probably in other videos, depending on which ones you've watched. I use -1 as kind of a flag value, and that's a convention that's real common. If we're doing like a search method and it doesn't find anything, it might return -1. And so that gives us a couple things we could do. So for example, we could check if the return is exactly -1. We could check is the return less than 0. It makes it real easy to work with. Okay, so after this withdrawal, let's go back to trying to withdraw $1,000. We want to check and see if that actually worked. So what we can do is we can take a look at that return value. If test account.withdrawal equals negative 1.0, then I want to print out a message, insufficient funds. Okay, so let's run that and see if it works. It says insufficient funds, and then it proceeds to print out and show that we still have the $500 that we deposited, but nothing changed with that withdrawal. And if I put it back to a reasonable amount, it doesn't output that message, and it seems to have worked correctly. So the last little change I'm going to make to my code is I've got this owner name that is implemented with just that single underscore, and that's I think very common among Python developers to do it that way. For our purposes, since we are specifically talking about concepts like encapsulation with object-oriented programming, I think we want to go with the stronger route for now, and obviously it'll be up to you depending on, it probably depend on context for if you're working on individual projects. Often it comes down to whoever your supervisor is and what they want, or whatever the team's kind of standards are. But I'm just going to use that rename function to go ahead and encapsulate that the rest of the way with name mangling. And at that point, we've essentially finished this little demonstration. It's not very advanced, but it does show everything we need to know. We've got our instance variables named in a way that that makes it clear they're not supposed to be accessed. I've got getters for everything that we need to be able to find out about. I've got setters. I've got only one of those in this case to be able to change the name of the owner. That you might have to do that in real life, right? Somebody gets married or legally changes their name. And then I've got these modifier methods, deposit and withdraw, that give us a way to manipulate the balance appropriately instead of just setting the amount of money. With that, I think we're good to go. If you have any questions about any of this or you need some assistance, be sure to reach out.